Okay, today we're going to talk about circles, central angles, and arc lengths of circles. All right, the mathematical definition of a circle is the set of all points that are equidistant from the center. So the center of a circle and then all the points that are the same distance away, okay? And you're probably familiar with the word radius. Radius is the distance from the center to the outside of the circle, and then the diameter is the whole distance across the circle, okay? The central angle might be a new word for us. The central angle is sort of the angle formed by like two radii or the diameter in a radius. So if we're looking at this one, angle APC, say that this is about 130, that would be called a central angle, okay? So then we have these things called arcs. Over here on this picture, we have this red arc. This is called a minor arc because it's less than a semicircle. So a semicircle is half of a circle. You guys have probably heard that word before. But a minor arc is smaller than a semicircle. So in this case, RS is a minor arc. And the notation that we use is capital letters, and then it's got like a little arc above it like that. Okay, a major arc is larger than a semicircle. And to name this one, you actually have to use 3 letters, because if you only use 2 letters, you don't know if you're talking about RS here or RS being the big one. So for this one, you would name this capital RTS with the kind of half circle above it. Okay? All right, so now we'll practice naming minor arcs, semicircles, and major arcs. It says name all the minor arcs of circle O, and we'll just name like 3 of them or so. Okay, so let's say that I want to name this one. Okay, I would call that DE, and then you put kind of the half circle symbol above it. You could also call this one ED. It's kind of like a line segment. You can write it either way. Okay, so then we could name this one AD, or you could also call this DA. And then one more, let's do one more here, AC or CA. All right, now the next one says name all the semicircles. We'll just name 2 or 3 here. So a semicircle means that it's half of the circle. So in this case, this would be a semicircle because it's using the diameter AE. Okay, to name this, we can't call this AE because AE would be talking about this blue arc, or it could also be talking about this arc that I haven't highlighted. So in this case, we're going to have to use the 3 letters again, ABE, like that. The arc on the other side, we could call ACE. That would be the other half of the circle, the other semicircle. Okay, so then to name the major arcs, we'll just name a couple of them here. Major arcs have to be bigger than a semicircle. So if I start at A and I go around to E, that's only a semicircle. So if I go to C, that would be called a major arc. So this orange piece would be considered a major arc. Now there's a couple ways that you could name that. You could call it ADC, or you could call it AEC. And either way, they mean the same thing. Okay. Let's see, let's find another one. Let's start at D here. Well, it says, name all the major arcs that contain point A. Okay, so here's another one. We could talk about this blue arc here. And that one has a couple ways that we could name it. We could call it DAE, or we could also call it DCE. Okay, so we cannot call it DAC because that means that would be the endpoint there. So we'd know that the D and the E would have to be your endpoints. So they would have to be on the front or the back of your name. Okay, and then a quick concept to talk about here. It says that the measure of a minor arc is equal to the measure of its corresponding central angle. The same thing goes for a major arc, or a semicircle, is equal to 180. So what this means is that if you have an angle measure, so RST, the angle measure is 50 degrees, that means that the arc measure would also be 50 degrees. Okay, if we had a semicircle, it would be the 180. So if we wanted to find out the measure of the major arc here, TQR, we would take 360 minus 50. That would give us the the pink arc here would be 310. And also this angle on the inside would also be 310. Okay, so when we're talking about arc measure and angle measures here, we do need to talk about, they are the same. Okay, if we're talking about adjacent arc, remember that adjacent means right next to. So if I'm talking about this pink arc and this blue arc, you would say that they are adjacent to each other because they have exactly 1 point in common, okay? So they're like right next to, okay? And then, so we had segment addition postulate, we had angle addition postulate, now we have arc addition postulate, which works pretty much the same way, saying that arc AB plus arc BC would equal arc ABC, okay? So if this was, I don't know, 30 degrees, this one was 80 degrees, then you know that together, the blue plus the pink would equal the 110 degrees, which is probably not accurate based on that picture. Okay, so finding the measure of each arc in this circle here. Okay, you have to kind of think of this as like a pizza, okay? We know that a pizza has 360 degrees in the whole thing. All right, so it looks like this slice right here is 32 degrees. This slice is 58 degrees. We need to figure out what these other two slices are. So we can do this a couple of ways here. We can take the fact that a half of a circle, so half of the circle is going to have 180 degrees. So I could take 180 and subtract out the 32 degrees here to get the measure of that angle. So that would be 148. All right. Then we could also figure out that we could also find this angle right here by doing the same thing on the other side. So if we take 180 and subtract out the 58, we get 122. Okay, so it's kind of like breaking up a pizza into different degrees. And we kind of did that with our hexagons and octagons and stuff like that. So for the first one here, I want to find the measure of arc BC. Well, they already gave us that one, so that one's kind of easy. So that one's just 32 degrees. All right, the next one is BD. That's this. Well, we know that BC is 32, and we know that CD is 58. So if we take the 32 plus the 58, we would get 90 degrees. So that's using the arc addition postulate. Okay, then for the next one, ABC. So let's see, ABC, well that looks like it appears to be a semicircle. So that would have to be 180 degrees. And then for the next one, AB, well we already figured that out, it was 148. All right, the next thing that we're going to talk about is circumference, and you've likely found circumference before. Remember that the formula is, so circumference is 2 times pi times the radius, or you've also maybe seen the circumference being pi times the diameter. Okay, so those are the two formulas for circumference, and you can use either one. It just depends on if you have the radius or if you have the diameter. You would use either one. And the radius is 2 times the diameter here, so that's what, the radius is half the diameter. That's why this formula works. Okay, so that's the distance around the circle. That's how many feet. It's kind of like perimeter. When we were talking about polygons, it's sort of the same thing. Okay, so you label this with just like inches or meters or whatever. You don't do square inches or square meters. All right, so if we look at this problem, it says a car has a circular turning radius of 16.1 feet. So that means from the widest distance here is 16.1 feet. That would be the radius of that big circle. The distance between the two front tires is 4.7 feet. Okay, so that means that the radius of our small circle would be 4.7 feet less than the 16.1. So if you take the 16.1 minus the 4.7, you get 11.4. Okay, so then what we need to do is asking us how much further does the tire on the outside turn or travel more than the tire on the inside. because you know that the outside is making a bigger circle compared to the inside tire. Okay, so it's saying if you drive the car in a circle, how much further is that big one going than the small one? Okay, it says to give your answers in terms of pi and a decimal approximation. So we're going to take the big circle, we're going to find the circumference there, and we're going to take the small circle and find the circumference there, and then subtract them. Okay, so since we have the radius, I'm going to use 2 times pi times, and the radius of my big one is 16.1. So that gives me 32.2 pi. You can just leave the pi behind it and just multiply the 2 times the 16.1. Okay, and then the small here is we would take 2 times pi times the radius of 11.4, which gives us 22.8 pi. Okay, so now we want to take the big minus the small, 32.2 pi minus 22.8 pi. What would that give us? Actually, we don't need to leave this one in terms of pi because it doesn't come out to a nice number anyways, but if you do calculate that out, you get 29.5 feet. That means that for every time that car makes a circle, the outside tire is going almost 30 feet further than the inside tire. Okay, so then what we're going to do is we're going to find arc length, okay? So in a circle, we don't want to find the circumference, but now we don't want to find the whole circumference. We only want to find part of the circumference. That's called arc length, okay? That's what, when it's asking for arc length, it's asking you to find a part of the circumference. And since this is a part of the circumference, what we're going to do is set up a proportion, because proportions, we know what we're doing is finding a portion of the whole thing, okay? So we know that we can use, so this looks like a really big ugly formula, but it's actually not that bad. You just follow the directions, okay? It says circumference of the whole circle, okay? Let's just give a random circle here with a radius of 2, okay? So if the radius is 2, that means that the circumference of the whole thing would be 2 times pi times 2, okay? So this is the whole thing. What I want to do is the whole thing has 360 degrees, okay? So this is representing the whole circle right here, okay? But I only want part of the circle, okay? So let's just say that I only want 80 degrees. Say that this is 80 degrees. I want to know how long 80 degrees is. So we want to figure out what is 80 degrees. How long is that? So it's going to look like this, okay? What is the circumference for just 80 degrees versus the whole thing, okay? So let's try one of these. It says find the requested arc length. Give your answer in terms of pi and the decimal approximation. So if we look at this one's asking for us to find the arc xy, okay? We know that the diameter is 16 and it looks like the angle measure that we're trying to find is 90, okay? So I'm going to set this one up using the proportion. So 360 degrees would be the whole circle, okay? So I know that the circumference would be pi times the diameter of 16, all right? And so I don't want to find 360 degrees, I only want 90 degrees of that circle. And I want to figure out what is the circumference of only 90 degrees, which I'm sure most of you know is just 1/4. Okay, and then we have to think back, okay, how do you solve a proportion? Okay, you're going to cross multiply. So I get 360x equals 90 times 16 pi. Okay, and then now we can just calculate the 90 times the 16, and I get 360x equals 1,440 pi. Okay, then we divide by 360. I get x equals, and then that's 4. And don't forget to put the pi there. That's very, very important. If you don't write the pi, and you just write 4, that would be completely incorrect. Okay? So, and it also wants the decimal approximation. So we're going to just type in 4 times pi, and I got, we'll round to the nearest tenth, 12.6. And then this is just inches. This is not square inches because it's not area. Okay? So let's try another one. Now in this one, we're trying to find the length of a major arc here.